Hey guys, I want to do a quick review with you before you take your quiz tomorrow. And I'm going to go back over some of our algebraic solutions to sinusoids and just say a couple other things, and I hope that we get a lot of good grades. So I've got this example here of a sinusoidal equation in terms of cosine. I'm going to ask you three questions about it. I want to know what is the amplitude, and I want to know what is the period, and I want to know what is the phase shift. Okay, so let's just answer these. The amplitude is the number that's in front of the sine or the cosine, regardless of if it's positive or negative. So our amplitude here is 8. Now the period is a little trickier because pi over 9 is not the period, but the period comes from this number after the cosine. We have to do a little math here. So we know that the period is 2 pi divided by that number b, which means I have to do 2 pi times 9 over pi. And once we do that, we should get that our period is 18. Excuse me. Okay, the phase shift is inside the parentheses. I don't see any problem with this. We are doing very well with phase shifts, and so we know that that is working opposite of what we think, so it's right 1 inside parentheses. Alright, so what I want to do next is I want to be able to solve this equation, and I also want to be able to find the function value. I'm going to solve the equation algebraically, and then we'll go back and use a calculator to find the function value. So what I want to do is I want to find out when the function, when does y equal 6? And so what I want to do is take my equation and set it equal to 6. And I'll tell you on your quiz that you have to show your work and you have to do all the algebra behind it. So let's write down when this equals 6. Sorry, I'll catch in my throat. Alright, the first thing I'm going to do is subtract 2. So I'm going to have 8 cosine of pi over 9 times x minus 1 equals 4. And then I'm going to divide both sides by 8. So I'm going to get cosine of pi over 9 times x minus 1 equals 1/2. So what I'm going to do now is I'm going to do the arc cosine of both sides. And so I'm going to do, even though we could do that by hand, I'm going to do that on the calculator. And this step right here is very important whenever you do arc cosine of both sides, because that's where we have to write two equations. So let's go back and ask our calculator from the home screen. Alright, what is the arc cosine of 1/2? Alright, now we're going to get a decimal. Now, do you happen to know what that is in radians? In radians, that is pi over 3. And you could probably believe that because 3.14 divided by 3 works out to be 1.04. But I'm going to keep it in decimals for now. So I'm at 1.04719. 1.0472 is what I'll write. So I'm going to have pi over 9 times x minus 1 equals 1.0, yes, of course, I forgot the number, 1.0472. Back to my pen. And then after you do this, you have to write plus 2 pi n. And then we're going to have another equation over here, which is going to be pi over 9 times x minus 1 equals the negative of that. Remember, with arc cosine, one equation is what the calculator tells you plus 2 pi n. The other equation comes from the negative of that. If this were a sine example, the first equation is what the calculator tells you plus 2 pi n, and the second equation is pi minus what the calculator tells you plus 2 pi n. So let's finish this up. We're going to divide both sides by pi over 9. So I'll have x minus 1 equals, so I need to do this divided by pi over 9 on the calculator. And that is 3. And then 2 pi divided by pi over 9, I think we already know what that is. That's 18. That works out to be our period, plus 18n. And then on this side, I'm going to get x minus 1 equals, this will work out to be negative 3 plus 18n. So now to finalize this for x, I'll get x equals, I'll add 1 to both sides, 4 plus 18n. And then add 1 to both sides over here, and I'm going to get x equals negative 2 plus 18n. So let's see if we can't, that's our general solutions, and let's see if we can't get the first 3 positive values. The first positive value is not negative 2, it's 4. The second positive value is negative 2 plus 18, which is 16. And the third positive value is 4 plus 18, or 22. Let's go see if we agree with those answers for the first 3. 4, 16, and 22. Alright, so let's go back to our calculator here. And let's graph the line y equals 6. Come down here so I can see it. Go to the graph screen. Alright, so I'm going to do second trace, number 5, just first curve, second curve, and then we want to get our cursor close to this very first intersection. And it works out to be, looky there, x equals 4. And then the next one, first curve, second curve, second curve, guess 16. And I believe it or not, the next one is, what did we get? 22? Alright. So anyway, now what I want to do from the calculator is find the values from the calculator. So let's say on the quiz tomorrow, I ask you to do something, and I didn't say you had to use a calculator, and I just wanted to find something like f of 3. F of 3 is not asking you for set the function equal to 3. It's just saying if we plug in 3, what will we get for our y coordinates? We want to replace our x with 3. One way to do this is I'm going to go back here to my y equals and turn off this second equation. From the graph screen, I'm going to ask for a value. And I just hit second trace. I want a value at 3 from the calculator, and that's 8.128. So let's just recap here what we've done to review. Amplitude, period, and phase shift simple questions. We did some general solution questions by hand showing the algebra with the first 3 general solutions, and remind us on the calculator how to find a function value by using our second calculate command. The last part of your quiz will be a sinusoid question, like the ones that we've been doing in class the last several days, where you'll have some points from a word problem and you'll have to graph a sinusoid, and then you're going to have to answer some questions about that. So you might want to review either the video or some of the examples that we've done. I hope that you guys do great, and I will see you guys tomorrow in class.